Hello, good day, ladies and gentlemen. Welcome back once again. Today we'll be evaluating this definite integral here involving the natural logarithm. We have the integral from 0 to 1 of the natural logarithm of 1 minus x all over x dx. Now let's get started. Now let us recall the power series expansion of the natural logarithm of 1 minus x. We have the natural log of 1 minus x. This is equal to the negative sum as n goes from 1 to infinity of x to the power of n all over n. Now let's call this integral I. We have I is equal to the integral from 0 to 1 of the natural log of 1 minus x all over x dx, and this is equal to the integral from 0 to 1. So from here we have the negative sum as n goes from 1 to infinity x to the power of n all over n, the whole of this over x dx, and we can pull this sum outside of this integral, right? So we have the negative sum as n goes from 1 to infinity. We have the term here 1 over n. Then we have the integral from 0 to 1 of x raised to the power of n all over x dx, right? So from here we have I is equal to the negative sum from n1 to infinity 1 over n times the integral from 0 to 1. Now with the law of exponents, so we have x to the power of n minus 1 dx. Now let us evaluate this integral from here. So the integral from 0 to 1 of x raised to the power of n minus 1 dx, this is equal to, the property of the logarithm. So the integral of x raised to the power of n is actually x raised to the power of n plus 1 over n plus 1, right? So here we're going to have x raised to the power of n minus 1 plus 1 all over n minus 1 plus 1. From here we have the limit from 0 to 1. And from here this simplifies to x raised to the power of n all over n, limit from 0 to 1. So if you insert the upper limit from here, we have 1 raised to the power of n over n minus 0 raised to the power of n, that is the lower limit, over n. This simplifies to just 1 over n. From here we have I is equal to the negative sum as n goes from 1 to infinity 1 over n multiplied by the value of this integral here, which is 1 over n. From here we have negative sum as n goes from 1 to infinity of 1 all over n squared. Let us recall the Riemann zeta function. We have the Riemann zeta of p. This is equal to the sum as n goes from 1 to infinity of 1 over n to the power of p. So from here we can see clearly that our integral I is equal to the negative Riemann zeta of 2. And this is equal to the negative Riemann zeta of 2 is what? Pi squared over 6. And this is the answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.